Hello everybody. In this new video, we will discuss about pH meter and pH metric titration. We all know that pH is a very important physicochemical properties of solution. That is why accurate measurement of pH is often required. pH meter is an analytical instrument that directly measures the pH of a solution. We will discuss about its principles, its calibration, and its use in pH metric titration. Besides that, we will discuss the advantages and disadvantages of pH meter. Now, electrodes, those are reversible to H plus ion concentration, are called pH sensing electrodes. Hydrogen gas electrode, green hydrogen electrode, and glass electrodes are of that type. In pH meter, generally glass electrode is used. Now, glass electrode is basically an ion-selective electrode that contains a membrane that is sensitive to one particular ion in solution. The membrane can be made of glass, ionic crystal, or a liquid. Most widely used electrode of this type is the glass electrode. Glass contains sodium plus ion. Exchange equilibrium occurs between H plus ion and Na plus ions of glass in solution. This exchange of charge produces a potential difference. A silver chloride electrode is in dilute solution. Dilute HCl solution is used as the internal electrode. The bulb is dipped in solution whose pH is to be measured. Another reference electrode have calomel electrode here is required to complete the cell. In modern glass electrodes, there are combination electrodes in which glass and the reference electrodes are arranged in a piece of equipment. Now, before using a pH meter, we have to calibrate it. Now, what is the procedure of calibration? See, there are three knobs in the front panel of the instrument: temp, temperature, cal means calibration, and mode. First, we have to set the temperature to the experimental condition. Now, we have to insert the electrode to a standard pH 7 buffer solution. If the reading shows otherwise, then we have to adjust the cal knob so that the reading shows 7.00. Likewise, following the same procedure, we have to calibrate the instrument in pH 4 and pH 9.2 standard buffer solution. Now our instrument is ready. So now we are ready for pH metric titration. Say acid base titration, specifically acetic acid NaOH titration. We want to determine the strength of the acid. For that purpose, we have to take a definite amount of acetic acid in a beaker. We have to dip the glass electrode into it, and we have to take the pH reading. A standardized NaOH solution is to be taken in a burette. Make sure that concentration of NaOH is about 10 times to that of the acid. Add NaOH dropwise to the acid solution, shake it, and take the reading. From measurement, we have a data set of number of drops of NaOH versus pH. Now we have to plot them. The left hand figure depicts the typical variation of pH with drops of NaOH. From the plot, we can obtain the equivalence point as indicated in the graph. Sometimes derivative plot, that means del pH by del n versus n, is plotted to get the accurate equivalence point. We got an utilization point at 35 drops. We can convert it into volume to the burette drop count. Now from V1S1 is equal to V2S2, we can estimate the strength of the unknown acid. At last, pros and cons of a pH meter. Among advantages, a glass electrode can be used in presence of a strong oxidizing and reducing agent. It can be used in viscous or semi-solid medium. In presence of high molecular weight substances like proteins, it can be used. On the con side, the glass membrane should not be allowed to dry. Glass electrode shows an alkaline error above pH 9, and observed pH is sometimes larger than the actual value. Thank you all.